Hey there. So understanding the cylindrical coordinate system is easier, much easier, when we understand it with respect to the Cartesian coordinate system. So let's see. The Cartesian coordinate system, much like any other coordinate system, has three axes: the z-axis, the y-axis, and the x-axis. Okay, so the main thing, the main point, or the main line that's drawn is this perpendicular that's dropped from the yz plane on the xy plane, or you can say it's a perpendicular that's dropped on this xy plane. Just simply, you can see that because it's obviously clear that it's dropped from the yz plane. So this perpendicular is important because this perpendicular is going to come in each and every coordinate system. So right here, this coordinate, hence I have colored this perpendicular blue. I've given it a blue color. So now seeing this thing, okay, so since this perpendicular is parallel to the z-axis, we consider this perpendicular being a subset of the z-axis, or being a part of the z-axis, or let's say it's a point, or it's you can say an ordered pair of the z-axis that's being plotted here. Now this y-axis is the green line. We have plotted let's say some ordered pairs of the y-axis here, so hence we get this green line. So this is the y-axis, this is the z-axis, although we know this is, so anytime you find a line parallel to any axis, you can actually consider that parallel line as the same axis. So if, let's say, there was a line parallel to the x-axis, I would say that the parallel line is also an x-axis. Okay, so that's basically the concept that we get over here, the y-axis and the z-axis. Now there's this black kind of a line that you see here, beginning from the origin. So what's this line about? This line is actually, let's say this angle is 90 degree because the x-axis is perpendicular to the y-axis, and perpendicular to the y and the z-axis, and y-axis is perpendicular to the z-axis as well as x-axis. So same thing applies for everything. Now since this is the y-axis, or this is the line parallel to the y-axis, it has to be at 90 degree with the x-axis. So this triangle that I'm dotting it up right now is going to be a triangle, a right angle triangle. So a right angle triangle has this Pythagoras theorem. I hope most of us know Pythagoras theorem. So the Pythagoras theorem says that the hypotenuse is equal to under root of side square plus side square. So let's say this is one side, y is one side, x is the other side. So this is the hypotenuse, obviously. So it is going to be equal to under root x squared plus y squared. Now this under root x squared plus y squared, this hypotenuse, everything that you see on this Cartesian coordinate system is going to appear in any coordinate plane or any coordinate system that we're going to look into. So moving on to the cylindrical coordinate system. In cylindrical coordinate system, this is what happens. Let's draw the z-axis, the y-axis, the x-axis all over again. Although I know I could do that in the same plane, but it would just make it all messy. Okay, so here, as I said, everywhere the perpendicular will be dropped. So again, I'll be dropping the perpendicular, and there I go. The perpendicular is dropped from the, as I said, the YZ plane to the XY plane, or you can just say it's a perpendicular that's dropped on the XY plane. Now let's draw a parallel line parallel to the y-axis. This time I've changed the color. But anyways, I'm going to write the names of the axes, so it's not going to be confusing. Okay, so as you can see, the same thing has been drawn again, but here I've written the first thing I did was obviously drop the perpendicular on the xy plane. So that's the z-axis, and we have the y-axis again and the x-axis. Now again, I'm going to draw the line from the origin, but here I'm going to name the line. I'm going to give the line a name, and that name would be nothing but r. Okay, so this line is going to be the radius of the cylinder, or instead of r, you can also call it a rho, or you can also call it an a, anything you like. But usually in questions in the exams, you either see an r or rho, but for now we would be studying using the rho, because we want to avoid being confused while learning the spherical system. So in spherical system it's r, and in cylindrical system it's rho for us, so as to avoid confusion. Otherwise you can use both r and r, but we would be saying to it that we are finding an equation between the spherical and the cylindrical r, so that will be really confusing if we use r's for both of them. So let's go for rho, and one more thing will be added over here that was not there in the Cartesian plane, and that would be an angle. So I'm going to draw an angle right from x-axis. So any angle that comes in a cylindrical plane begins from the x-axis, the positive x-axis, and goes like that to the r, or to this line, this resultant kind of a line. Now if this r is on the negative side of x-axis, so the phi is going to be negative. The phi is going to be clockwise, so that means it's going to be negative. And by the way, this clockwise and anti-clockwise can only be seen if you see it from this angle, from upwards. So from, if you have a side, an overlook from the upside, that's when you're going to actually see whether it's anti-clockwise or it's clockwise. Otherwise you can not you cannot understand it so well. So anyways, we are not going to name the angle as theta, we are going to name it a phi. Again, phi is going to appear in the spherical coordinate system, and this phi will be equal to the phi of the spherical coordinate system. So this is how it begins, from the x-axis to the rho, or the radius. Now why is it called the cylindrical coordinate system? It's called the cylindrical coordinate system because when we draw yet another parallel line to this, okay, and when we try drawing some shape, we'll end up with this thick cylinder. So that's the reason it's named the cylindrical coordinate system. By the way, the Cartesian coordinate system, or the Cartesian coordinate plane, can be redrawn or can be restructured into a cuboid. So let me do that for you. There you go. So it's easy to learn it in shapes. So we have a shape for the Cartesian coordinate system, that's a cuboid, or you can say cube, but I would rather call it a cuboid. And for the cylindrical coordinate system, it's a cylinder, obviously. Now we are going to combine both of them, and we are going to find a relation between both of these planes. Let's do that. So there's just going to be one single plane that you're going to see with both of these values. So how am I going to do that? Obviously, beginning with the axis, I'm going to draw the perpendicular as usual. Perpendicular is going to be z every time. And then I'm going to draw my y, my x. This is my x, and the middle thing, that's the rho. Now we all know from the Cartesian coordinate system that this rho, this hypotenuse, is equal to, the rho is equal to under root x square plus y square, right? So that's known. That's like, that is not changeable. That's constant. Okay. So now, yeah, I forgot the phi. So let me just do the phi there. Yes. So we have the phi, we have the z, we have the y, we have the x, and we have the rho. So we know now what rho is. Rho in terms of the Cartesian coordinate system is x square plus y square. And when we move forward to the spherical coordinate system, it's going to be a bit different. But for now, let's just focus on rho being under root x square plus y square. Now, what's phi? Well, any angle is usually found by using the tan inverse or arctan. So we're going to do that. So as you can see, phi, tan is always, tan, for your information, tan is opposite by adjacent. So here, what's the tan? The tan of phi is going to be, I forgot to put the tan there. So tan of phi is going to be, let's say, tan of phi, opposite is y, adjacent is x, because tan, the phi is touching the x, so adjacent is x, opposite is phi. This is the hypotenuse, so we're not touching the hypotenuse anyhow. So let's write the tan phi. Tan phi is equal to y by x. So phi is going to be equal to, obviously, tan inverse or arctan y by x. There we go. So we have our tan. Let me put that in the box. Yes. So now we have our rho and we have our tan. Phi. So rho and phi are done with respect to the Cartesian coordinate system. Now the final thing that's left is z. So do you see any changes in this z and this z? Is there any difference between this z and this z? I don't think so. So we're going to just do a very simple thing over here. Yeah, you are right. We're going to equate them. Simple, isn't it? Great. So we kind of did the cylindrical versus the Cartesian coordinate system at the same time, and we tried understanding what is cylindrical and what is Cartesian coordinate system together. So we came across a few formulae. That's rho is equals to under root x squared plus y squared. You don't really have to remember all these formulae. You can just go on and you can just understand. It's just not something you need to remember and memorize for that matter.